Okay, so the last time we did something like this, I don't know exactly what happened, but the audio cut out, so I'm remaking some of these videos. So the last video that should be in this unit is solving linear systems of equations by graphing. So we're going to go with substitution today. And I've got 3 examples. So if you are familiar with substitution but you need a refresher, what I suggest is taking some time and trying to work these problems out and then looking at the solution. If you are brand new to this, I still encourage the same thing. If you get stuck, then watch the video. Or if you're unsure of how to actually even do substitution, watch one example, then try the next one. Okay, so we're going to start with example 1. So we've got 2 equations. And so I'm going to start with the easiest equation here, in my opinion, is the first one. You can easily solve for x by getting rid of that negative 7y and adding it to the other side of that equation. So whenever you're solving by substitution, you start with one equation, solve it for one variable, and then substitute the expression on the whatever side you solve for back into the other equation. So if I start with equation 1, then I'm going to end with equation 2, solving for one variable. Okay, so I'm going to go ahead and start solving this first equation for x in terms of y. So x minus 7y equals negative 11. And what I can do is add 7y to both sides of this equation. So remember, variables are not like terms of the constants. So 7y does not commute with negative 11 because 7y is a variable term and negative 11 is a constant term. So, and then on the left-hand side, negative 7y and positive 7y, they're equal in value but opposite in sign. So they will add to 0. So I'm left with x equals 7y minus 11. So all you do is append that negative 11 to the right-hand side and then put 7y in front. So what I'm going to do with those things, this expression 7y minus 11 is in equation 2. I'm going to substitute it in for x. So everywhere I see x in equation 2, I'm going to substitute 7y minus 11 into it. So I'm left with 5 times 7y minus 11 plus 2y equals negative 18. 5 distributes, and I'm left with 35y minus 55 plus 2y equals negative 18. Okay? So then, right here, 35y plus 2y are like terms, so I get 37y minus 55 equals negative 18. I'm going to add 55 to both sides of that equation. And let's see what 55 minus 18 is. It is indeed 37. Okay, so that's going to work out nice. So 37y equals 37. So divide both sides by 37, and I get y equals 1. So if y equals 1, then you can find x. So there's 2 parts to this. Once you solve one variable, one equation for one variable, you take that variable and plug it back into the other equation. So over here, I've solved for x. X is equal to 7y minus 11. So since y is 1, I can actually plug or substitute 1 back in for y. So I've got 7 times 1 minus 11 is x. So that means x is equal to negative 4. So those are a pair. So my point of intersection, right, if you remember the last video, and if you're not familiar with graphing lines, you probably should go watch that video or something similar. Whenever 2 lines intersect, they intersect at a coordinate, if they intersect. So in this case, these 2 systems, these 2 equations are going to intersect the system. Will intersect at negative 4, 1. Okay? So that's one example. let's go with example 2. And I wrote that problem wrong again, so let me make sure I've got that written correctly. Should be 3. There. Yeah, that's written correctly now. So this is kind of very similar to the other one. What I notice here is that the second equation, right, if I label that one equation 1 and that one equation 2, the second equation has smaller numbers. So it's easy to divide some numbers by 2 and kind of get a sense of what the number is. So what I'm going to do is start with equation 2 and solve it for y, okay? Just because I know that when I solve for and isolate 2y, I'm going to have to divide the coefficient 2 out. And so I can divide 4 by 2, and then 3 divided by 2 is going to be 1.5. So if you're confused on that, just give me a second. Hopefully it'll become a little clearer, but we're going to start this problem. So again, if you're new to this and you want some practice, try solving this out on your own. But if you get stuck, unpause the video and take a look at the solution. So negative 4x plus 2y equals 3. So I'm going to add 4x to both sides. So I get 2y equals 4x plus 3. And then I divide every term by 2. So I get y equals 2x plus 3 over 2. So what I've got is y equals 2x plus 3 over 2. And so what I can do is take that whole expression and then substitute it in for y for the other equation. The other equation, not that one. Because we started with equation 2, and we want to end with equation 1. So I'm going to plug 2x plus 3 over 2 into that equation. So I get 7x minus 8 times 2x plus 3 over 2 equals negative 12. And I'm going to distribute that 8. So I get 7x minus 16x plus, no, it's going to be minus because it's a negative, my bad, negative 8 over 1 times 3 over 2 equals negative 12. So if I take a look here, negative 8 times 3 is negative 24. Negative 24 divided by 1 times 2 is going to be negative 24 divided by 2. So negative 24 divided by 2 is going to be negative 12. Equals negative 12. And so 7x minus 16x is actually going to be negative 9x. So you're left with negative 9x minus 12 equals negative 12. So if I add 12 to both sides, this gives me 9x, negative 9x equals 0. So now all I have to do is solve for x. So negative 9 is being multiplied, so I'm going to get rid of it by dividing. And you can check my arithmetic here, but 0 divided by anything is just 0, except for 0 itself. So x equals 0. So if x equals 0, then I can plug it into y. So that's one part of the coordinate. So this implies that y is equal to 2 times 0 plus 3 over 2. So y is equal to 3 over 2. So to sum it up, the point of intersection for this system, and that's just example 2, is 0, 3 over 2. So maybe I should talk about that for a second. So what I'm saying is if I graph these lines, 7x minus 8y equals negative 12. If I graph this line and this line, you'd actually see their intersection to be 0, 3 over 2. So visually. So I hope that helps. I can show that in another video if you would like, kind of hand in hand, but I figured I'd just focus on solving by substitution without having to take the time and talk about more than one thing. I just don't want to confuse anyone. So we've got one more here. which is 3x plus 9y equals negative 6, and then negative 4x minus 12y equals 8. So what I want to do is take one of these equations and solve it for either x or y, and then plug it into that expression into the other equation. So I'm actually going to pick equation 1 because I see that they're smaller numbers, and I can divide everything by 3. So since I can divide everything by 3, I'm going to pick 3x to isolate and solve the equation out. So equation 1, I'm going to subtract 9y from both sides of the equation. I get 3x equals negative 9y minus 6. So divide every number by 3, and I get x equals negative 3y minus 2. So that is cooked and canned. So now all I have to do is plug that into the second equation, right? We started with equation 1, and we're going to end with equation 2. So everywhere that I see an x in equation 2, I'm going to substitute this in. So I've got negative 4, negative 3y minus 2 minus 12y equals 8. So negative 4 distributes. So I'm left with 12y plus 8 minus 12y equals 8. And then when I combine 12y with negative 12y, actually all my variables cancel out and I'm left with number equals number. So anytime you get a situation like this in a systems of equations, it doesn't mean that you screwed up the problem. As long as you've done your math correct and you've checked your steps and you've done everything correctly and you get number equals number and you get the same number on both sides of the equation, then what it means is that every single value of x and y on one line is a solution for both systems. And you might be wondering, like, how could this be? Well, I'm actually going to show you that because I think it's important. So I'm actually going to go over here to Geogebra. We're going to start the calculator. Let me make sure. Nope. Oh, there it is. Yeah, right there. So over here in Geogebra, see if I can get to it. If I let it load first, if I type that first equation, which was 3x plus 9y equals negative 6, Geogebra